Supreetha. Welcome to my math class. So in the previous lectures on limits, what did we study? We studied about the concept of limits. Yes, LHL, RHL, L'Hospital's rule, sandwich theorem, and we solved some problems. Yes. So in this class, let us solve some more problems related to the exam JEE. Okay. Yes. So the first problem says limit x tending to 1. Yes, let me write that down. Yeah. So the solution, okay, so limit x tends to 1 secant pi divided by 2 power x into log x, right? So secant x is the reciprocal of which trigonometric function? Can you recall? Was it sine, was it tan, or was it cos? So yes, so the secant is the reciprocal of cos x. Yes, so let me write it as 1 divided by, I can write secant because it is a reciprocal of cos. I can write it as 1 divided by cos. Yes, and pi divided by 2 power x remains as it is. Now, let me add and subtract 1. Okay, let me add 1. Yes, and I'm subtracting 1 to this log. Yes, and in the denominator, what is sine 90 minus theta? Sine 90 minus theta. Remember, sine 90 minus theta is cos theta. Yes, so we have cos theta over here. Can I write it as sine? You can write 90 degree in the form of radians as pi by 2. Yes, so I'm writing it as sine pi by 2 minus 2 power x. Yes, now what I'm doing is I'm multiplying and dividing. Okay, I'm multiplying, dividing x minus 1 in the numerator, and I'm multiplying and dividing this angle in the denominator. Okay, so I would get limit x tending to 1, yes, log of 1 plus x minus 1 divided by x minus 1, okay, whole thing divided by sine pi by 2 minus pi by 2 power x, okay, whole thing divided by pi by 2 minus pi divided by 2 power x. So what did I miss? I had to write x minus 1 over here, okay, and then pi by 2 minus pi divided by 2 power x over here. So I'm multiplying and dividing. Even here I'm multiplying and dividing. So now let me take limit x tending to 1. Okay, let me find limit x tending to 1. Yes, let me write it as log x itself. Okay, divided by x minus 1. So I have log 1, which is 0, and here 1 minus 1 is 0. So let me apply L'Hospital's rule. Okay, limit x tending to 1. Yes, I would get 1 divided by x divided by 1. Now if you apply the limits, what would you get? You would get 1 divided by 1, which is equal to 1. Yes, let me take the denominator term. Yes, that is limit x tending to 1 sine pi by 2 minus pi by 2 power x, okay, divided by pi by 2 minus pi by 2 power x. Yes, so now what is the formula? Let me write down the formula for you guys. D divided by, if I have d theta into say sine theta, or let me say sine a theta. Okay, I would have to differentiate. Okay, so a is a constant, right? Let me take it as something else. So yes, if I have to differentiate d by dx of sine y, I would write it as, yes, differentiate sine y. That is, you would get cos y. Yes, again you would have to write dy by dx because we are differentiating with respect to x. Y is a function of x. Okay, so you can differentiate sine y. You cannot say that it is constant because here y is a function of x. Okay, so I would have to differentiate this. That is, I would get cos y, but then again I would have to differentiate y too because it is a function of x, right? So what would I get over here? I would get limit x tending to 1. Okay, what would I get? Cos pi by 2 minus pi divided by 2 power x. Okay, so if I differentiate, yes, I would have to differentiate this again. Differentiating with respect to x, that is pi by 2 minus pi divided by 2 power x. Okay, this thing divided by, what is differentiation of pi by 2? So this is L'Hospital's rule. Yes, so we are differentiating the numerator and then again we are differentiating the denominator with respect to x. This is L'Hospital's rule. Okay. So yes, so in the denominator we have differentiation of pi by 2 is 0 minus differentiation of, let me take 2 power x to the numerator, I would get 2 power minus x. Yes, what is the differentiation of a power x? Yes, what is the differentiation of a power x with respect to x? Can you recall? Yes, it was a into, yes, a power x into log a. Yes, so what do we have in the place of a here? We have 2. In the place of x, we have 2 power minus x. Okay. So yes, we have limit x tending to a cos pi by 2 minus pi divided by 2 power x. Yes, so these both are same. So let me write it directly as minus pi. So in the place of a, we have, yes, a power x here, we have 2 power minus x and then log 2. This divided by, okay, divided by the same thing, minus pi 2 power minus x log 2. So in the numerator and the denominator, these terms gets cancelled. Yes. So we have cos pi by 2 minus cos, okay, I am applying the limits, okay. So 2 power 1, which is nothing but pi by 2. So I would get cos pi by 2 minus pi by 2, which is 0. Agree? Yes, limit x tending to 1, I would get cos 0. What is cos 0? Or 1, right? So now finally, if I zoom out, I can see that limit x tending to 1. So this term is 1. Okay. This term is 1. And even this term, yeah, this term is also 1. So what else is remaining? Yeah, let me write that down. Yes. What else is remaining? Limit x tending to 1. Okay. I have x minus 1 divided by pi by 2 minus pi by 2 power x. Yes. So what was the question? The question was, let me write that too, which is our LHS. Okay. Limit x tending to 1 secant pi divided by 2 power x into log x. Now, what happens if I apply the limits here? What happens if I apply the limits? I would get 1 minus 1. Yes, 0. I would get pi by 2 minus pi by 2 again. It is again 0. So what should I do? Let me apply L'Hospital's rule. Okay, L'Hospital's rule. That is limit x tending to 1. Yes, I would get 1 here, divided by differentiation of pi by 2 is 0. And let me take it from here. Yes, what did we do? We have pi by 2. Differentiation of pi by 2 is 0 minus, what is the formula for a power x? Wasn't it a power x into log a, which is log 2 over here? Yes, so let me write that here. We would get minus 2 to the power minus x into log 2. So if x is 1, what would I get? I would get 1 divided by minus 2 to the power minus 1 into log 2, or this is equal to minus 2 divided by log 2. Yes, do we have this option here? Let me check. 2 divided by minus log 2. Okay. Did we miss a pi? Yes, we have missed a pi. Over here, yes, we had pi, right? Pi divided by 2 power x. So I would get a pi over here. So minus 2 divided by pi log 2. Option, yes, minus 2 divided by pi log 2. That is option B, right? So our correct answer is over here. Okay, I hope this is visible to you guys. Yes, minus 2 divided by pi log 2. Okay, so moving on to our next question, that is tan x minus x divided by x square tan x. Okay, let me write that down. Yes, solution. So yes, substitute in the place of x, apply the limits. What would you get? What is the value for tan 0? When I ask you the value for sine 0, tan 0, you should get a unit circle. Yes, you should remember the unit circle. Yeah, from that, what is the value of tan 0? Isn't it 0? Yes. So sine 0 is 0. Cos 0 is 1. So 0 divided by 1 is 0. Yes. So we would get 0 minus 0. So we already have x square over here. So directly you can say that denominator is also 0. Yes. So now, before applying the L'Hospital's rule, you see I have tan x over here. I can write it as sin x divided by cos x. Yes. So let me do that. X tending to 0, sin x divided by cos x minus x whole thing divided by x square sin x divided by cos x. Yes. So now take the LCM in the numerator. What would you get? Yes, limit x tending to 0 sin x minus x into cos x divided by, I have a cos x here that comes to the denominator, into x square sin x divided by cos x. If you observe deeply, one of the terms gets cancelled. Yes, that is cos x and cos x gets cancelled. Okay. So now what else can you do? Now you apply the limits. What are you getting? Again I'm getting 0 in the numerator, 0 in the denominator. Now you apply L'Hospital's rule. Yes. So what is L'Hospital's rule? You just have to differentiate the numerator and then the denominator, right, with respect to x. Okay, so here you have limit x tending to 0. Yes, you can try by taking sin x divided by x, multiply and divide, and then I guess you would have to apply L'Hospital's rule again. Yes, so let me directly apply. What would I get? Differentiation of sin x, it is cos x. Yes, we have a product term here, so differentiation of product terms would be first differentiation. Okay, imagine I have d by something, d by dx of x into x square. Okay, so I would have to differentiate. Yes, I would have to differentiate 2x x square. If I differentiate first, keep the other term as it is. Again, if you have to differentiate x, keep x square as it is, and differentiation of x is 1. Yes, what if I have to differentiate d by dx of x into y? As I told you, y is a function of x. Yes, so when I am differentiating y, keep x as it is, so y would be y dash. What is y dash? Dy by dx. Yes, y dash is dy by dx. Okay. Next, again, okay, plus, if you're differentiating x, keep y as it is, and then you would get 1. Okay, so over here I have x into cos x. So let me keep x as it is. Differentiation of cos x is minus sin x. Yes, again, plus differentiation of x is 1. Okay, what else? In the denominator we have again the product rule. Yes, I'm differentiating x square. I'll keep sin x as it is, plus I'm differentiating sin x, so I would get cos x. Now let me multiply this minus term. Yeah, so I would get limit x tending to 0 cos x plus x sin x minus cos x whole thing divided by, yes, I would get 2x sin x, or let me take out x common. Yes, okay, x plus x square cos x. Okay, so you see over here in the numerator we have cos x plus cos x minus cos x. Yes, so what would we get? It gets cancelled out. So here one x and another x gets cancelled out. So what do we get next? So you see we have sin x over here and sin x over here. Let me plug in that sin x divided by x. We have the limit x tending to 0. Yes, so let me write it as limit x tending to 0. Yes, so I would have to multiply and divide it by x. Yes, so this thing divided by 2 into sin x divided by x into x. Yes, I would get x cos x. Okay, so now what happens? This term is 1, agree? This term, this is 1 and this is also 1. Yes, we have x here and even 1x here. So everything gets cancelled. So what do we get at the end? We get limit x tending to 0, 1 divided by 2 plus cos x. Yes, so after applying the limits, we would get 1 divided by cos 0 is 1. So that is 1 divided by 3. Okay, so this is option A, right? 1 divided by 3. Okay, so now moving on to our next problem. That is, they are saying limit x tending to infinity sin x divided by x plus log x divided by x. Let me take the first term. Okay, that is solution. Yes, limit x tends to infinity sin x divided by x. Okay, so you see sin x or sin infinity lies between or varies between -1 and 1. Agree? So what do I want now? I want 1 divided by x, right? I want sin x divided by x. That is our question. When does this sin x lie between -1 and 1? When the limit x approaches to infinity. Yes, when limit or x approaches to infinity, our sin x varies between -1 and 1. Yes, so can you recall the unit circle in our trigonometry? Yes, what happens at infinity and infinity? The y-axis, yes, minus infinity and infinity, yes. So we want this sin x by x. So let me keep it as it is. What is 1 divided by infinity? Isn't it 0? Less than limit x tending to infinity sin x divided by x. This is also less than 0. So yes, can I write it as sin x divided by x? Yes, we have sin x divided by x is equal to 0. Okay, because it is varying from where? 0 to 0. It doesn't make sense. So it is equal to 0. Yes, so now what do we have? Log x divided by x. Yes, limit x tending to infinity. Log x divided by x. What is log infinity? Isn't it 0? Or is it infinity? Log x divided by x. So here we would get infinity by infinity form. Okay, so because log infinity is infinity. Therefore, let us use L'Hospital's rule. What is L'Hospital's rule? We would have to differentiate the numerator with respect to x. So we would get 1 divided by x. Differentiation of log x is 1 divided by x. Okay, divided by differentiation of x, that is 1. Now by applying the limits, I would get 1 divided by infinity, which is equal to 0. Yes, now what did we get? Limit x tending to infinity sin x divided by x plus limit x tending to infinity log x divided by x is equal to what? 0 plus 0. Yes, we got 0 over here and 0 over here. What is 0 plus 0? It is 0. Yes. So which is our option A. Okay. So we solved 3 problems in this class. Yes. In the first one, what did we do? So the reciprocal of secant was cos. Yes. And then we added and subtracted 1 over here. And then we divided this term x minus 1, multiplied and divide. We multiplied and divide the angle. Yes, we cannot take this as 1 because we have x tending to 1, not 0. Yes, so for the numerator term, we applied L'Hospital's rule and we arrived at 1. For the denominator too, we applied the L'Hospital's rule. Yes, and we arrived at 1, so numerator and denominator became 1. So for the remaining terms, again we use the L'Hospital's rule. Okay. And then we got our required limit. Yes. So in the next problem, we first tried simplifying it. Yes, where tan x is sin x by cos x, right? So we tried simplifying it. Again, we arrived at indeterminate form. So we applied the L'Hospital's rule. We differentiated them. But still there was a 0 by 0 form, I guess. Yes, 0 by 0 form. Yes. So then what did we do? We found sin x and the limit is x tends to 0. So we multiplied and divided by x. Yes. And after some simplification, we arrived at our answer, that is 1 divided by 3. Okay. So what did we do in our last problem? So you see sin x. So the given limit is x tending to infinity. So as we know that sin infinity varies between minus 1 and 1. So we divided by x, we applied the limits and we arrived at sin x divided by x when x tending to infinity is 0. And then for log x divided by x, what did we do? We got infinity by infinity form. So we applied the L'Hospital's rule. Yes. And we found that even the value of log x divided by x as x tending to infinity is 0. Yes, by adding 0 plus 0, we got 0 itself. So our answer is option A. Yes, I hope you understood. Thank you.